All right, folks. Good morning, everyone, and welcome to February South Atlantic Third Thursday Web Forum. I gave folks just a few extra minutes, two it looks like, because I know how much folks like to cut it at the end to sign on to these things. But hopefully everybody can hear me. My name is Lori Barrow, and not only am I your host for today's presentation, but I also serve as the Information Transfer Specialist and USDA Forest Service Liaison to your cooperative. Now, I know most of you on the line are familiar with the overall format of the calls, but for those of you who may be joining us for the first time, as the name implies, each Thursday, on the third Thursday of each month, your South Atlantic LCC hosts a web forum that provides an opportunity to share information about what's going on within the cooperative and how it's getting done. It also serves as a chance for folks to ask any questions and provide input that will help guide the conservation future within the South Atlantic. So with that said, each forum has roughly the same agenda, consisting of a brief introduction of the presenter, followed by a 30 to 40-minute presentation. Following the presentation, there'll be a block of time set aside to ask any questions that you may have, and then the remaining time will be dedicated to brief updates from your cooperative, followed by an open discussion where anybody can ask questions about what we're up to and how it's getting done. So before I get into the heart of the forum, just a few logistics. It sounds like most folks have already muted themselves. However, I'm going to mute everybody. I'm getting a little bit of static and feedback. If you have any questions, you can type them directly into the chat box, which I'll be monitoring throughout the presentation, or, of course, you can hold them until after the presentation during the open discussion. If you do use the chat box and wish your questions to be read during the open discussion, please remember to send the note to everyone so that we can all look at it. And then, of course, at any time during the discussion, all you need to do is *6 to unmute yourself. Okie doke. Now, before I mute everyone, is there any immediate questions, comments, or concerns? All righty. I'm going to mute everyone.
The conference is now in silent mode.
Okay, so, well, with that, let me first say that on the line today from your cooperative, we have our coordinator, Ken McDermott, Science Coordinator, Rua Mordecai, Socioeconomic Adaptation Coordinator, and National Park Service Liaison, Janet Jakir, GIS Guru, Amy Keister, and Brad Pickens, a postdoc fellow at NC State, who recently joined us to help integrate some of the South Atlantic indicator models into the blueprint. That said, presenting today will be Adrienne Wooten, a graduate research assistant at NC State and climatologist at the State Climate Office of North Carolina. This will be Adrienne's second time presenting during the forum. Back in April, she presented on her work on the Defense Coastal Estuarine Research Program, and today she'll be presenting on a synthesis of climate model downscaling products for the Southeastern United States. And I've actually had the chance to hear this presentation before, and Adrienne has been kind enough to agree to come back and explain the differences between various climate models and provide several suggestions on their use. So not to reveal too much about Adrienne's presentation of work, Adrienne, I'm going to go ahead and hand it on over to you and let you take it from here and introduce yourself. So just give me a second to pass the little ball of power over to you. And just remember to *6 to unmute yourself.
All righty then. Thank you, Lori. That's a wonderful introduction. Now let's see if I can share my presentation or application. There we go. Can everybody see that all right?
It's coming up now. We can see it, Adrienne.
Excellent. Okay then. So what I'm actually presenting on today, I think we actually ended up rescheduling this as it was getting canceled, if I'm not mistaken, during our lovely government shutdown earlier this year. But anyway, I'm presenting on work that we have been doing for a little over a year now regarding the synthesis of climate model downscaling products for the Southeast U.S. Yes. And this was work that was funded by the Southeast Climate Science Center, but it also incorporated several different individuals, as all the logos might suggest here on the front, from USGS and from Florida State University, providing a lot of guidance for us, in addition to quite a good collection of ecologists. I particularly can thank Rua for a lot of his work involved in this. But with that said, we'll dive right into things. So we have a lot of global climate models out there, but they have very coarse scales, generally on the resolution of 100 kilometers plus. And if you think about your different habitats and species and what have you, they generally they operate at finer resolutions than that, of several kilometers perhaps. So we use a process called downscaling, which refers to translating information from these global climate models to regional or local scales. And generally you can get to resolutions that are much finer, of 50 kilometers, 20 kilometers, 12 kilometers, some instances as fine as 4 kilometers. And I've even seen some recent publications of such downscaled data, or downscaled data sets, as we refer to them, data sets created with downscaling that have resolutions of 800 meters. But just as there is no one standard global climate model, there's no one standard method for doing downscaling. And as a result, there's many such downscaling techniques. And as a result, you could do a quick Google search and find 30-plus such data sets exist. And these are just some examples of names of different data sets, or more appropriately, acronyms for names of different data sets. Some of them have very long names. But the interesting thing, of course, is you're looking at all of this, and for someone who has no knowledge of what the differences are and how these data sets are created, it can be very challenging to decide which data set to use. And often I get the question of, okay, which one is the best? This is a very interesting question, and not an appropriate question actually either, because just as if you think of it, some techniques will do better with certain variables than others. Some techniques will be better at capturing extremes in temperature and precipitation than others. And some techniques will be much better and able to reproduce wind speed and wind direction and evapotranspiration and other variables that may be important to whatever kind of decision you're making or whatever species you're studying. So asking me which one of these is the best is like asking me my opinion on which one of these two cars is the best. You're going to have a Prius, you can use that for one kind of thing. It was built with certain intents in mind. Or you could have a Ford F-250 right there. Hey, that was built with certain intents in mind too. They're best for what they're intended for. They're not best for one thing in general. They might be the best for you, but they're not the best for someone else. And the same kind of analogy you can treat with the different kinds of downscaling that's done, and with the different, even with the different global climate models themselves. They are best at different things. So asking me which one is the overall best isn't necessarily an appropriate question. And we got into this a lot when we started working with ecologists who are starting to use a lot of these downscaled data sets much more commonly in recent years. And so there's a need to start understanding all of these differences. So a lot of the project we focused on here, making available in the final report that we're actually hoping to going to be published here in March very soon. So regarding what each of these downscaled data sets provide, which data sets are more accurate for different variables, and also talking about the connections between climate and ecology. Are we as climatologists satisfying the needs of the ecology community, and what can the ecology community do for us to help us satisfy the particular needs in climate information? So our focus with this project was on comparing and evaluating the differences between different available downscaled climate change products, or what I'm going to refer to pretty consistently, you've probably already noticed, as downscaled data sets. These were the 6 that we've chosen to start when we started this evaluation, and the synthesis, I should say. And they represent a very wide range of downscaling techniques themselves that were used to create them. I'm not going to go through and name off all of these different things here, but this is just to give you a sense. The top 3 were created with one kind of downscaling technique, and the other 3 were created with another category of downscaling techniques, and we'll get into that here in a moment. Aside from looking at accuracy, we wanted to make sure we helped folks in the CSC and the LCCs also understand that each of these downscaling techniques are different. You have in the different world of downscaling, you have 2 main kinds of downscaling techniques. The first is a statistical downscaling approach, which is to say you have an empirical relationship between your observed data and your large-scale historical information. That's used to build some kind of statistical model relationship, and that model is then used in the future to predict what will happen locally based on the large-scale information. You also have, because the techniques are different, I forgot, the other kind of technique is a dynamic downscaling approach, which is to say there are models that are similar to the global climate models themselves, applied at a regional scale and producing data at a much finer resolution. The two different kinds of techniques lead us to differences in what kinds of variables are available from each of the resulting downscaled data sets. They also lead to differences in what emission scenarios are used. They also lead to how many global climate models are used. And this is actually important because you think of the fact that each global climate model represents the sensitivity of the climate just a little bit differently, the sensitivity of climate to emissions just a little bit differently. And the result from this, of course, is that there's a general consensus among us to try and use as many global climate models as possible when doing downscaling to provide the widest range of what is possible, a full characterization of all the uncertainty in the projections locally. In addition to the GCMs, the emission scenarios, and the variables, you're going to see, of course, there's different spatial resolutions and different domains that each of these data sets cover. There's also different temporal resolutions. And when I mean temporal resolutions, well, some of the output might be daily, some of it might be monthly. If it's monthly output, you can't necessarily consider, okay, my species is vulnerable to number of days of precipitation over an inch. Well, if it's monthly, it doesn't help you get that, right? And also, of course, they have different time periods that they cover. Not all of them cover a continuous span of time from 1950 through 2100. Some of them have only slices of 30 years that you could use for your particular analysis and studies. And why won't the slide flip? There we go. Looking at an example of the differences in the metadata, you can see here our 6 data sets as an example. And you can see just very quickly looking at this that there's very different spatial resolutions. There's very different output temporal resolutions of the data. There's also a very different number of global climate models that are used in the downscaling by each of these data sets. And I highlight these two in the 2 different boxes because the data sets in the green box on the top were created with a dynamic downscaling approach. And you can notice they have finer output data. They have more time periods. They're doing like 30-year chunks. And there's fewer global climate models that are used. So as a result, you can see here an interesting thing coming up with the fact that the dynamic data sets and the statistical ones in the red box below it have very different aspects of temporal resolution and time periods and the number of global climate models. And a lot of the reason for this is related to the fact that in dynamic downscaling, it's actually incredibly computationally intense. I'm actually working on a couple of simulations right now for Puerto Rico, where we ran an initial calculation and we realized, oh, great, if we run it this way, it's going to take us 20 years. It's going to take us 3 years to do it. Wonderful when it's a 2-year funded project, right? And this computational intensity of it limits the amount of global climate models that can be used in downscaling with a dynamic downscaling approach, just because it can take a very long time to run. On the other hand, you do get wonderful fine resolution, temporal resolution output if you need that. The statistical ones, yes, of course, they are less computationally intense, and you can see there's a lot of global climate models that can be used as a result, but they are also dependent upon the observed data. And there's not a really long hourly record of observed data to build those statistical relationships used in statistical downscaling. And so a lot of the output from statistical downscaling is daily, monthly time output, as opposed to where you can get hourly output in the dynamic models. Or I should say from the dynamic models. There we go. Here's just another way of looking at it. On the top left, you can see the number of global climate models downscaled in each data set and the number of emission scenarios in the bottom right used by each data set. And again, I can point this out. Statistical is on the right, dynamic data set created is on the left. And you can see the computational expense, again, plays out also with emission scenarios. But if we continue and we go and look at both variables and emission scenarios, so on the left-hand side of this little table is temperature, precipitation, winds, and ET being evapotranspiration. And on the right side, you're looking at emission scenarios. from the AR4, actually the fourth assessment report, going from low to high emissions. So everywhere you can see a green arrow, that a green check mark, I should say, that data set has that variable in it. It has all the dynamically created data sets on the top have wind speed and wind direction and evapotranspiration. And why? Because, well, with the statistical output, which doesn't have it, it's because we don't have a very long observed record of winds and ET to be able to build a robust relationship for a statistical model to be able to downscale that from the large-scale data. But on the other hand, because you're relying on the full physics of the atmosphere in a global climate model, so fluid physics mathematically represented in a global climate model and in the regional models that are used in dynamic downscaling, you can get the full representation of wind speed, wind direction, and evapotranspiration out of the dynamic downscaling approaches that you cannot get out of the statistical downscaling approaches. But again, computational expense is a trade-off in this. You've only got one emission scenario in those dynamically downscaled data sets. You have 3 to 4 in the statistically downscaled ones. So this is a highlight on the metadata part of it. There's actually a lot more in the report, and please feel free to ask me when we're done if you'd be interested in getting a little bit more information out of that report. We know it's going to be published here hopefully at the end of March, but I'm certainly happy to talk with you further about other kinds of details and things that we've run across. So this is a question, of course, is when it comes to actually evaluating for accuracy, how do you evaluate all these data sets when they have such significant differences in metadata from each other? What we chose to do was we actually chose a common spatial and temporal resolution. And we picked the coarsest one out of the data sets and aggregated all the rest of the data sets to that resolution. So NORCAP is the coarsest, spatial resolution, 50 kilometers, so we aggregated all of our data sets to that. And we had a coarsest temporal resolution at monthly timescales. So we aggregated all of the data sets, temporally speaking, to that also and focused on monthly averages. We also focused on common parameters. So you could see there before that temperature and precipitation were in common between all 6 of them. So we focused a lot on that. And we looked at the means. We also looked at the variability, so year-to-year variability. We wanted to see if that was reproduced, as well as the frequency of different extremes. And finally focused on a historical time period, common historical time period between all 6 of the data sets. And this turned out to be 1971 to 1999. So just briefly through the metrics we used for evaluation, we focused on bias when it came from the means, just really a simple difference between like average temperature estimated minus average temperature observed. Standard deviation difference, very similarly to the bias really. We were using this to get an assessment of how well each data set reproduces the observed historical variability. And the reason we look at this as important is that it's related to the frequency of having such extremes. It's related to, in the case of temperature, for temperature variability, it's related to the frequency historically of really hot periods, really cold periods. So reproducing the right historical variability tells us a bit that the data set will hopefully reproduce the same frequency of extreme conditions that might be important for different studies. Speaking of extremes, we noticed when working with our ecologist colleagues that there's not one common particular critical threshold for any set of species and what have you. So we chose, in one hand, to look at the probability distribution functions that were produced by each data set for several subregions across the Southeast, just to be able to get a sense of all the extremes at once. Does it really fit the full distribution of temperature and precipitation for each of these subregions? We also looked at what we called annual cycles. Obviously, it's hotter in the summer and colder in the winter, making sure things like that are represented. And in this case, we also incorporated a root mean square error and a correlation to give it a little bit more, an additional level of quantitative evaluation. And all of this is in comparison to an observed data set. And for those of you familiar, we actually made use of the PRISM monthly data for our observed data set in this analysis. You'll see this map come up a few times. This is actually the 14 sub-regional domains we focused on in the Southeast U.S. South Atlantic LCC actually falls into a couple of them in this particular evaluation, but you'll see this particular map come up a few times in the following slides. What I'm going to do now with the rest of the time is just to highlight a little bit of the important things we found in evaluation. The report itself has much more in it, and I'm certainly glad to go into it. with anybody who's interested in hearing a bit more. But from here, I think we can start on temperature. And while it's not hot, I felt it was appropriate to be somewhat corny and keep this in here. So yeah, it's not hot outside, but we'll keep on going. The January mean monthly temperature bias is what's shown here, and you'll see this kind of layout pretty commonly in the next couple of slides I have. On the bottom are the 3 statistical downscaled data sets. On the top are the 3 dynamically downscaled data sets. And you can see here the bias in January mean monthly temperatures over the historical period. And noticing really quickly, right, that the 3 dynamic data sets are very cold, whereas the other ones are much more along the lines of normal. But you can see some patterns, particularly in the southern Appalachians, with regards to having a warm bias on one side of the mountains or a cold bias on one side of the mountains and the opposite bias on the other side of the mountains. So an interesting thing comes up when we look at this and we consider it. We can also go further because you'll see a similar kind of thing show up on the next one, which is this is July mean monthly temperatures, where it's still cold in a lot of cases with the dynamically downscaled data sets. But you also see that really sharp pattern, particularly in this statistical downscaled data set of a sort of a dipole of biases, if you will, on either side of the southern Appalachians. One thing I want to point out at this point with the dynamically downscaled data sets, that is, there's one thing that is not commonly done. Each global climate model has a certain amount of systematic biases that are in it, and this is bias just related to the model running, and it's something that can be corrected for. And so do the regional climate models also have such set biases in them. What is very common to do, and the reason we chose to do this, it's very common to do, is that the raw output from a dynamically downscaled data set will not have those systematic biases corrected already. And therefore, it's very important for anyone who wants to use it to make sure that they correct it before they use it. Either that or to focus specifically on the projected change and not to focus on not the exact temperatures that are shown in the future, if you will, but to focus on the change between future and present time. And a lot of the reason they don't do a particular bias correction on the output of a dynamic downscaled data set is because there's not one standard method to do bias correction either. And that is a whole separate discussion we could have regarding that. But on the contrast, with the statistical downscaled data sets, many of the statistical techniques used involve some kind of bias correction already. So that's why you're seeing such a difference in this case with temperature in particular. It's much colder because there's a bias in the dynamic ones that hasn't been removed from the raw output as it has been with the statistical output, with the statistical downscaled data sets, I should say. Come on. And you can see this again also. There'll be several graphics like this, so I'll just describe what's going on here. On the top left-hand side, you'll see the annual cycle for the mean temperatures for this particular region. This is the southern Appalachians. And you can see there on the means on the top left side, the 3 dynamic data sets, again, are too cold for much of the year. And this is, again, related to that issue of the raw output not having the systematic kind of biases pre-corrected in it. And that is something that needs to be done before a user should use it. On the bottom right-hand side is related to the means is the annual cycle for the standard deviations. And this is to say the year-to-year variability in each month. And you can see you have a higher amount of variability in the winter, which is normal in that time of year, in that area in that time of year, and a lower variability in the summer. And, well, you have a fairly good representation from all of those data sets in that aspect. And you can see on the top, actually, what I have up there in that corner is the root mean square error. In this area, actually, for the means, the Center for Climatic Research's data set, CCR, was actually the lowest error with regards to the mean, and the second lowest for regards to the variability. So it's a fairly good data set to use. One thing I would point out, though, and I would remind people, is that this is over this entire region. And you saw previously with that data set how there was a dipole of being really warm on one side, really cold on the other side. It is important to keep in mind that if you're looking at very small areas, this is going to give you a guide for what's going on over in that whole region. But it's important to come and talk to a climatologist who's familiar with how these data sets work when you're working with a region that is much smaller, because there are going to be some subtle variations over that region and how well that data set performs, particularly in complex topography. We can look at this another way. Actually, we can look at this for the probability distribution functions, and you have January in the top left corner and July in the bottom right corner, and you can again see that the dynamically created data sets are much colder. But what you can also see is, and particularly in January, a tendency for the statistical data sets to be a little less variable. They don't capture as much of the extremes as we would like, though they're very accurate in capturing the means in January. And you can still see this somewhat also in July, in the summer in this region, but it is not as bad. And this is what I wanted to point out actually with the bias correction. You can see here on the left-hand side, this is the NARCAP mean monthly temperature bias for September. Not bias corrected on the left, bias corrected on the right. And I want to point out here that, of course, once you bias correct it and you remove that constant systematic cold bias from these, you get a very similar representation in the remaining errors that are left behind after you remove the systematic bias. But what also shows up is there's still that little bit of bias in the southern Appalachians related to complex topography. And this, in the case of the regional and global models, that is related to the fact that you can't represent perfectly the topography in that region. The topography is represented coarsely, just as the atmospheric temperature and patterns and wind patterns and what have you are also resolved very coarsely. So this is one of the reasons that this shows up once you do a bias correction on the dynamically downscaled data sets also. So this is why it's important to consider bias correction, but it's also important to consider that there's going to be some very subtle variations over complex topography that could be very important. Okay, we're going to move on to precipitation. I'm not tired of snow, but you all may be, so I won't necessarily be talking about snow, but I had to throw this in here given our recent amount of snow here in Raleigh. Precipitation is one of the hardest variables for any data set to capture on a monthly and a daily timescale. And this is actually for the northern Gulf Coast of Florida, looking at the annual cycles. And you can see there are some very interesting variations where you have your dry period in October through December, really, and a wetter period during the spring and summer in this particular area. And you can see in general, each of these data sets do a good job of capturing the means in precipitation over that region through the year. On the other hand, when you look at how well the variability of precipitation is captured, that can be a very different beast. In this case, it's very much along the lines with the best one for capturing the variability. So again, representation of extremes. Remember the variability here, the standard deviation is connected with how well the extremes are represented. So you can see here also that the Bauer BCSD actually does a decent job in representing the variability in this region. But I should point out, this is actually relatively flat area, less complex in terms of topography in that region. If we go back to our friend in the southern Appalachians, we can see another very interesting sort of pattern come in. A lot of the means are, again, represented well, with the exception of the one downscale data set known as clearance 10. And the variability, however, is not really well represented by anything in this particular region through much of the year. The closest is actually the data set out of Wisconsin. But again, the topography also plays a role in here, too. Just to give you an instance to make it important is that historically we know that the wettest place in North Carolina and the driest place in North Carolina are 30 miles apart between Asheville and Lake Toxaway. Very, very big change in precipitation amounts annually and along the different months, actually, over a very short distance. So it's important to realize that these represent the entire region, and they're good for talking about the region as a whole. But if you need something need some information about what's going on at a smaller region, I would very much encourage you to come talk to me or to another climatologist that's very familiar with that region and how all these data sets perform in that region. Now, speaking of precipitation, we want to look at the mean precipitation bias. And I bring up September because September is the peak of hurricane season here in the southeast U.S., and hurricanes provide a good amount of the precipitation for our region. And we can see here there is some tendency for it to be dry, particularly in the downscale data sets, except for South Florida, where it's wetter than it should be in the modeling environment, in the downscale data sets, I should say. And on the other hand, in the statistically created ones, again, it is a little dry in the Carolinas and a little wetter in South Florida. But that is not so much what I'm interested with. Remember again that hurricanes also provide us a lot of driving rain and a lot of those extremes in precipitation, which influences the year-to-year variability that is there historically. What I want to point out with this one, which is our standard deviation difference. So in this case, think of it as if it's brown, it's really underestimating the variability. It's not producing enough floods and really dry periods. On the other hand, if it's really bright green, it's producing too much in terms of floods and really dry periods also. So way too far on the extremes if it's green, and not enough extremes if it's brown. And here in September, we notice one particular aspect that comes out really strongly here in the Carolinas and in Southeast Virginia. And you can see it very clearly here. There is a very strong tendency in all of these data sets to underestimate the September variability, the interannual variability, the variability of precipitation in September, as shown by our standard deviation difference here. And this is related to the fact that the global climate models, while they can tell that there is a hurricane there, you cannot represent the full-blown physics, the full bands and rainfall and structure of a hurricane in a global climate model. In a regional model, the regional models can pick that up and reproduce more of those bands of heavy rain that's associated with a hurricane. But remember that a statistical approach isn't based upon the physics of the atmosphere. It's based upon statistical relationships between observations and the large scale. Well, if the large scale doesn't give you enough of an indication of a hurricane, then that statistical approach isn't going to provide a hurricane either. And this really influences the year-to-year variability in September in the Carolinas in particular. Another way to look at this is the annual cycle for rainfall in the eastern North Carolina region. Again, a lot of the means are very well represented, except for that one particular aspect with Clarence 10, where it put a monsoon in July, apparently. We also can see here, though, the high standard deviation here in September, and this is again related to the fact that we have hurricanes that come and influence the amount of rainfall we get and the extremes in rainfall we get in eastern North Carolina. So you can see also, though, that there's nothing that really reproduces that spike in variability that should be there. So this has been a very interesting challenge, and it's a very common thread in the problem that has existed not just in these 6 downscale data sets, but in many others. So that's a highlight, broad overview of a lot of different things that we've discussed and discovered in doing this particular synthesis and evaluation. One of the things that came across a lot when we were working with our ecologist colleagues, and Rue and others might remember that we had a workshop last May where we brought together a whole collection of ecologists and trying teasing out what the community here in the Southeast really needed from the climate modeling world and from all these kinds of downscale data sets, what information was really needed. One of the things we recommended and pointed out with this report is a very common thread that we got, is that a guide is nice, and all that we have produced in this report is a guide. But having access to a person is a great thing. And this is something where I think, looking back on it, the LCCs and the CSC can be very helpful in making sure that if somebody's going to use local projections, that they can get a hold of someone who is a local expert, whether it be me or Ryan or Adam or whomever. But give me an expert if I'm going to be using these data sets so that I don't do so that I use it appropriately, and so that I get the best answer to my question or the most robust results in my impact study or vulnerability assessment. We also did a lot with the fact that this is very broad, overarching evaluation, and it should be very much, if you're going to look at these data sets yourself, evaluated very much based upon what you're going to use it for. What variables do you think are important to your species, to your decision? Evaluate those data sets and others that you're interested in based upon that particular fact. And of course, we very highly encourage that you should come and talk to a climatologist. I'm gonna hammer this over and over and over again until I get a lot of emails from ecologists now. But we do encourage you to come talk to us and have teamwork, because we think it will provide you with more robust results and also gives us much more insight into what we can provide and what we need to be providing as from the climatologist community for these kinds of local projections. So some other conclusions from the report itself: bias correction is a must for dynamic data sets. Do not use it unless you bias correct it or you get someone else to bias correct it for you and tell you how they bias corrected it. You're going to see issues with topography, particularly in the southern Appalachians, and there will be issues with representations of extreme rain from hurricanes in particular. So this is very important to keep in mind. And it's going to be a very common thing with several different downscale data sets, not just the ones that we've talked about here. Technique differences give you accuracy differences. And again, I am going to say this. Do not ask me which data set is the best. Come and tell me what you need, and then we'll talk about which data set is the best for you to use for what you need it to be good at. And, collaborate with us. We who are very familiar with it, we welcome doing these kinds of collaborations, and it helps us realize, okay, this is what we need to be providing for the people. And you get to learn from us, we get to learn from you. It's a wonderful situation. And, who knows? I think if you ask me, the collaboration can be wonderful, and who knows, it might be illuminating and explosive all at the same time. And that's fantastic to me. So some future thoughts and future work. As I mentioned, the full report is finally going to be released this spring. That's going to have a wonderful amount of information for every single subregion I've talked about. There's full analyses with everything, all of these different kinds of metrics and what have you that I've mentioned. We do very much recommend that this kind of analysis and evaluation be repeated with daily timescale parameters, because then we can get into such things as, okay, the frequency of the number of days with temperatures over 90 or 95 or under 32 or what have you, which might be a little bit more important to work with. An example here I have on the right is one of the things that's going to be included. We did do another version of all of those bias maps at a much finer resolution of 15 kilometers, with the exception of NARCAP, which doesn't have any 15-kilometer data for the Southeast. So all of that will be included in the report as well, which I'm hoping, we'll see how quickly USGS can turn it around for us, will be finished at the end and published at the end of March. I would be remiss if I didn't mention all the huge collection of people that were wonderfully helpful in terms of just the project team by themselves. So I will leave all of them up here in my contact information, and I'm happy to take any little questions.
All right. Thank you so much, Adrienne. I know from my own perspective that was, I always enjoy listening to you talk. You have an amazing ability to explain some of these detailed models in a way that's meaningful for folks like me who aren't familiar with the information, and great suggestions and disclaimers. And in case folks joined late, just a real quick thing before we open the floor for some questions. In case you want to reference this presentation or go back and look at some of the results, we are recording this right now, and it will be available on our site. So that said, we have some time now to answer any questions or comments that you have regarding Adrienne's presentation. Again, press *6 to unmute yourself, or feel free to type them directly into the chat box.
Hello, this is Chip Deutsch in Gainesville. Can you hear me?
Yep.
Obviously, water managers, planning for future water supplies and demand, this is pretty critical. And I'm just wondering whether your office or the this community of researchers running these regional models are working with Florida water management district managers when they're looking at long-term supplies, demand. There's a lot of work on MFLs, minimum flows and levels, and how much can be withdrawn from a particular area without causing ecological harm. And I don't know whether they're incorporating forecasts on future precipitation into those deliberations.
I'm not entirely familiar with everything that's going on with the water management district. I do know they are making use of a lot of the projections and information that is out of the Florida State group, specifically Vasu and Lydia, who are both up there on on the screen here, have worked with them on that. I do not know offhand everything that they're doing, but I can certainly put you in touch with them if you're interested in talking with them more.
Well, thank you. I was just trying to look for a general answer. I don't have a specific need.
I believe they are making use of precipitation and looking at some of the minimum flows and what have you. But I honestly don't know entirely everything that they're doing. So I would have to refer you to Vasu and Lydia.
Okay, thank you.
I see that. Two questions. How come there's no A1FI, which as I understand it is the trajectory we are on? And when can we expect AR5 model runs? Two great questions. One of the reasons there was not an A1FI included in a lot of these is there was, in some cases, an understanding and a hope that we would not be on an A1FI trajectory at this point. So that was one of the reasons it was not included in some of the data sets. And other reasons it might have been just in interest of time, people were not able to run any of these data sets, any of the A1FI emission scenario data. When can we expect AR5 model runs? The CMIP5 simulations with all the new emission scenarios have been completed, and I am starting to see several new downscale data sets being produced. Actually, Ed Maurer and Levi Brecky have produced a new version of their bias-corrected, of their BCSD data set with some CMIP5 data already from the fifth assessment report. At the time we started doing this analysis, a lot of that wasn't quite available yet. So that's one of the reasons we're hopefully going to be pursuing doing a little bit more evaluation and further synthesis and providing such information.
Any other questions for Adrienne?
One question. So does this take into account the hypotheses that tropical storm activity in the Atlantic will increase or change either in frequency or intensity of storms and hurricanes with global climate change?
Not in this particular analysis, and the reason for that is that because we focused on historical time period. When we do a lot of evaluations, we have to make sure that there's representation in the historical time period of what actually happened, and that gives us a sense further of how accurate and what the uncertainty is in the future projections. So in the sense of taking into account what we think is going to happen in the future, that wasn't part of the scope of this particular study, is to look at how hurricanes are going to change in the future. We wanted to look at how well their effects are represented in the current historical period, so that gives us a sense on how accurate they would be in the future period. So they do underrepresent the variability of hurricanes in the historical period, and I would very much expect them still to underrepresent the amount of precipitation from hurricanes in the future when they do occur. If they do occur less frequently, then there might be even less frequent than that, the amount of really heavy rainfall that there should be.
Any last-minute questions for Adrienne before we jump back to some South Atlantic updates? Now's your chance.
No, they've also got my email and my phone number at this point. So.
Yeah, and just again, folks, this is being recorded, and we will put both the recording and the presentation on our site so that you have access to it. And as Adrienne mentioned several times throughout the presentation, don't hesitate to contact your local friendly climatologist. Well, Adrienne, I think I'm going to take back the power, and thank you again so much for that great presentation. I'm giving you a virtual round of applause right now.
You're very welcome.
All right. Well, again, I'm going to jump back real quick to just some last-minute South Atlantic updates, and then following the updates, there'll be an opportunity for folks to ask any questions or comment on anything that they would like answered about the cooperative. So let me pull this presentation back up real quick. All righty. Okay, just get into a few updates. So we've been fairly busy here from the cooperative. I'm sure many of you have gotten our newsletters and some of our updates and posts that we've been sending out. And since I'm talking right now, I'll just go ahead and give my brief update. So as folks may remember, that the South Atlantic undertook its first annual report card last year. And as absolutely crazy as this seems, it's now time to check back in with you and get your thoughts of how the cooperative's been doing over the past 12 months. In the upcoming newsletter, you'll see a short survey, and it's an opportunity to voice your comments, concerns, or opinions, and the information gathered will be used to help guide future efforts and presented to the steering committee, and then delivered again in another annual report card sometime hopefully in April. So I just wanted to provide that update, and then I know Rua has a few other updates, and then Ken has a brief one. So Rua, I'll let you go ahead and provide your update.
Yep, so a couple of reminders real quick. A lot of you, being part of the South Atlantic web community, will have gotten the email reminding you about reviewing the draft conservation blueprint, so the version 1. So that review is due February 24th, and also the second opportunity right now to help guide where your cooperative's going, some feedback on potential blueprint uses. So some more specific prioritization about the types of things you would like to see your cooperative over the next year, work on trying to use the blueprint for. And things you think, hey, I don't think this current version should be used for these kind of things. So again, that's February 24th, which is Monday. So just a reminder about those deadlines, and you'll have gotten that in email. Another thing I wanted to mention to sort of keep your eye out on is that the marine part of the draft blueprint should be out and circulated by the end of next week, so we're shooting for February 28th. To add that on to the existing blueprint, that's the sort of the land and nearshore water part. And there's a picture over there that shows you the scale. Their outer continental shelf lease blocks is the scale we're working at. So we've had some virtual workshops on that, and the team is going to be reviewing, again, some of the results from that over the next week. And we hope by the end of the month to have the going all the way out to the sort of EEZ, the extent of U.S. waters part into the Atlantic of the blueprint out by the end of February. So keep your eye out for that. And that's all I got.
And good morning. This is Ken McDermott. Just wanted to give you a little update on the LCC Council. In previous web sessions, I've mentioned that the LCC network helped to form a council that's made up of federal, state, NGO, tribal, and representatives from Canada and Mexico as a support group for the LCC network, the full network, not individual LCCs. Well, that group had its inaugural meeting in February 4th and 5th. I had the privilege of being the one LCC coordinator representing the LCC network participating on the council, and I'm pleased to say that our hopes were fulfilled in that this council was made up of a lot of really good folks, well-positioned to support the network, and they unanimously confirmed that they believe in the idea of what LCCs are intending to do for conservation, and that they are going to work hard to support the network in a variety of ways. As you can guess, it's the inaugural meeting, so there's a little bit of forming and norming going on, but I would direct you to the LCC network website, which is at lccnetwork.org, where you can kind of find a good summary of that first meeting. So that's the story with the LCC Council.
Fantastic. Thanks, Ken. Just to give folks a heads up, the next Third Thursday Web Forum will take place March 20th, same time, same place, and we'll feature really accompanied by other South Atlantic staff, and we'll really focus on gathering insight and thoughts from you, our web community, and you're all part of this cooperative, which we will then bring to our annual steering committee meeting, which is slated for late March. So finally, we always want to make sure that folks know how they can get involved with the cooperative, and in addition to contacting any one of us directly, we operate a highly active web page. I'm willing to bet most folks on this call are already part of the web community, but if not, join the SALCC website, the South Atlantic LCC website, and get our monthly updates and share your ideas and recent research, and feel free to either engage directly with your steering committee representative or of course, give one of us a buzz. And with that, I'll open the floor for any additional questions folks might have or last-minute insights that they want to get off their chest before we sign off. Just remember to star 6 yourself to unmute. All right. Well, if there's no last-minute questions, it looks like we're going to end a little bit early and let folks get on with their morning and afternoon. I hope everybody has a great one, and just another huge thanks and round of applause to Adrienne for her great presentation. Again, it'll be available online, and looking forward to seeing y'all on the next Third Thursday in March. Thanks, everyone.
Thanks, Lori.